All right, hello friends. Welcome to Pre-Calc. I'm super excited that you are back here with me because today, as you've already seen, is going to be about even and odd functions. So the TEAC that we are examining in particular is P2D, and our learning goals are still all about transformations and really being able to describe those transformations from the parent function if we're given an equation and use our knowledge to determine domain and range. So to get us really introduced to even and odd functions, I think it's important that we first discuss symmetry. Um, Oftentimes we associate symmetry with balance, and it is true that one of the beauty markers is symmetry in someone's face. So we are going to investigate what it means for functions to be symmetrical and how we can predict symmetry of a graph from its equation. So let me clear these really quick. You didn't see that? Okay, so go ahead and look at the graph on the right. The equation for this graph is f of x equals x squared minus 2. And I want to see, what do you all notice about the symmetry of this function? Hopefully you notice that this beautiful quadratic is symmetrical over the y-axis. So it's symmetrical with respect to the y-axis. So to investigate a little bit further, let's find some concrete values for this function. So let's see, negative 4, if we plug in negative 4, we get 16 minus 2, I get 14. Negative 2 squared, 4 minus 2 is 2. And then I get negative 2, 2, and 14. So what pattern do you notice in these ordered pairs? What pattern do you notice? If you said, well, opposite x values produce similar y values, I would very much agree with you. We see that the y value for negative 2 and positive 2 are both 2. The y value for negative 4 and positive 4 both happen to be 14. So what we notice is that the opposite x values produce the same y values. Excellent. So let's go ahead and deduce. If you were given an equation, how could you check if the function has y symmetry without looking at the graph? Well, based on the previous question, hopefully one of the first ideas you have is plug in the positive and negative x value and see if they produce the same result. So let's look at this one now. So the graph of g of x equals x to the third minus 4x. What do you notice about this one? What do you notice about this one? This one might be a little bit more difficult to tell, but this one has symmetry according to the origin. So it's symmetrical with respect to the origin. So let's look at some table values. If I plug in -4, okay, so 4 times -4 is 16. 16 times 4 is 48. That's going to be negative. And then -4 times -4, positive 16. Hold on, let me check my math there. 16 times 4 is 64. So I should have -64 and then plus 16. So this is -64 plus 16. So that's going to give me -48. If I plug in -1, I'll end up with a -1. Let's see, plus 5. Pardon, plus 4. Give me 3. Get 0 minus 0, which is 0. Let's do 1. So if I plug in a positive 1, I get a positive 1 there. Minus 4 gets me -3. 4 to the 3rd power, that's going to give me positive 64. Minus 16 is going to give me a positive 48. So what do you notice this time about the table values? What do you notice this time about the table values? If you said, well, I'm kind of seeing a similar pattern to the other one, except instead of producing the same value, we are producing the negative version, both the negative and positive version, you are correct. You are correct. So essentially what that would mean is that g of -x produces the negative version of your positive x value. So let's deduce again. How could we check if the function is symmetrical with respect to the origin if we did not have that graph? One easy way would be to definitely plug in opposite x values, and see if we get opposite y values. Another way that I really like to do this is that if this is indeed true, then I will plug it in. So I would get g of -x. So let me plug in -x to the 3rd minus 4 times -x. And I'd see, okay, I get, let's see, -x cubed plus 4x. Okay, so that means if I take out that negative, I get x third minus 4x, which is my original equation. So I see that my proof is kind of validated there. So yeah, I could plug in x values. I preferably like to plug in my -x and see if I get my negative output. So let's jump into some notes here. All right, so some important ideas. So let's talk about even functions. So a function is even if it has y-axis symmetry. So go ahead and think of your quadratic function whenever you're thinking of even functions. I also like to think an even function is usually associated with even numbers for exponents. Okay, so essentially this would mean that negative x, y, is the same thing here as x, right? F of x equals f of negative x, as we saw in our exploration. So an odd function exists if it's symmetrical around the origin. So function is odd if it has origin symmetry. Essentially, you want to turn it 180 degrees and you should have the same function. You should have same graph. And a good function to think of whenever you're trying to ask yourself if a function is even or odd, always think about the cubic function here, where y equals x to the third. So our value of xy produces negative x, negative y. And just like with odd function or even functions, odd functions are usually associated with odd numbers for exponents. Excellent. So there's a lot of ways, right, we could figure this out. We can look at table values, we can plug in negative x and solve algebraically. We can look at the graph just in general and try to turn it in our heads. A function can be neither odd nor even. That's an important thing to remember. It doesn't have to fit into either of these categories. A function can be neither even nor odd. So don't worry if, let's say, you go through it and you're like, well, it's not even and it's not odd. That's okay. That can be an answer too. So let's check for understanding. I really have, I believe, just one. So let's go ahead and look at question 1 here. Pardon. So half of the graph of an odd function is shown below. Sketch the other half of the function. Okay, so there's a few ways we can go about this, right? So I know that it's going to be, if it's odd, it's symmetrical with respect to the origin. It's symmetrical with respect to the origin. So I would turn it 180 degrees and ask myself if I have the same function. Okay, cool. Let's see. Well, we have a couple ways we could do this. We could look at each value and plot it according to what the odd, if it is indeed an odd function, what it would produce. Or we could draw a line and try to reflect it over that in our head. So I guess let's go ahead and try and do that. So odd functions are reflected over the line y equals x. It's definitely really hard to do. So I might want to start with the table. Let's see if I can do this though. So this one, if it got flipped over, it would be like over here. Yeah. Well, I'm having a hard time with that. So essentially, let's just start with the tables and see. It should be symmetrical over the line y equals x. So let's see. If this is 0, 3, right, then that means I should have a value at 0, negative 3. Okay, cool. What about this one? This is another big one. So if this is at 3, 0, then I should have one at negative 3, 0. So it should look a little bit like this. Something like that. Okay, I definitely like it. I see that that small triangle here is reflected well. I'll color it in. I really like, it's nice to, when your head kind of makes sense of the flipping. So that looks like it got reflected well. Let me see this red here. And this looks pretty good too. It looks like it got reflected well. Okay, but I'm still missing this line here. So let me grab one more point. Let's do this one, which is 7, negative 2, which means I should have a point at negative 7, positive 2. Negative 7, positive 2. Great. Then I'll draw that line. Let me go back to black. Perfect. I love it. Okay, excellent. So conceptually, it can definitely be tough to sketch these, but you can do it. And if you're not sure, take it in pieces. Take it in pieces. All right, excellent. That's all I have for you today. I will be giving a couple questions to see if we truly understand what even and odd functions are. And I look forward to seeing you all next time. Take care of yourselves. Bye-bye.